Hello students, today we are entering into the new topic which is called as electric dipole. So very important topic for all competitive level. First we will discuss the basics and the board level thing, just like a basic one, and then we will extend up to the NEET level. So let us start the session now. The heading is electric dipole. So first let me come across the board level which you had been learned already. So we will see now electric dipole. When you consider electric dipole, there are points, major points that you have to understand. First point is two equal and opposite charges, two equal and opposite charges separated by a small distance. Separated by a small distance. Clear? Small distance depends on point of observation. Remember that. How come? Last class I discussed whether palm is big or board is big. People used to say board is big, but I used to say palm can be big, because if I put my palm close to my eye, I can't see the board. And I can say board is smaller, palm is bigger. So point from where you are seeing, that is important. Clear? That is minus q plus q separated by a small distance. For better understanding, we are taking 2a. Clear? Now, point number 2. Point number 2. The effect of dipole can be taken from the center of the dipole. Very, very important. Center of the dipole means every distance, whatever you are measuring, the distance should be measured from the center of the dipole, like from here to here. If you want to find electric field at point P, you should measure the distance from the center. And if you want to measure at any point Q, you should measure from the center of the dipole only. From the center of the dipole only. Point number 3. Point number 3. Vector, call it as electric dipole moment. Vector, call it as electric dipole moment, represented by P bar, which has both magnitude and direction, because it's a vector. It's a vector. What is the magnitude? It is defined as the product in between the length of the dipole. You can see the length of the dipole, that is 2a, into charge of the positive charge of the dipole plus q. And what about direction? directed from directed from minus q to plus q. Please mind it, the direction of dipole moment is from negative to positive. So it will be obviously, if I want to represent the direction, it should be p bar minus q to plus q. Please try to understand. Minus q to plus q. Clear? Now last point. People will think, let me write here. People will think now, fourth point. Tell me, there are three charges. Let me say minus 2q, let me say q, let me say q. So my straightforward question is there any dipole you are seeing there? Of course, as per the dipole definition, there will be two equal and opposite charges separated by a small distance. Right? Separated by a small distance. Okay, done? So here minus 2q, they are not equal and opposite. q, not equal and opposite. q minus 2q, not equal and opposite. Hence, the answer, people will say immediately, no sir, it won't form a dipole. But there is a slap on their face because point is there. Hiding point is there. Still, there is a dipole system. How come? For a dipole system, fourth point is, for a dipole system, mind it, for a dipole system, net charge should be 0. You can understand this. For a dipole system, net charge should be 0. How come? For a dipole, minus q is the charge, plus q is the charge. Net charge is minus q plus q. Answer will be 0. So if you see here, yes. Here also, net charge of this system is 0. Hence, it gives a dipole. No question, no second thought. Please mind it. Okay, done? Now, clear? The last point about the dipole, which you have to understand, fifth point. Fifth point. If 2a is very much lesser than r, like if this is the dipole and the point is which is r, which is at x, where r is much more greater than the size of the dipole, then the dipole is treated as short dipole. The dipole is treated as short dipole. Clear? So let us see now the other name of short dipole. The other name of short dipole is ideal dipole. The other name of short dipole is ideal dipole. Please try to understand. These are all the 5 major points that you should understand clearly and clearly. The first point explains about the definition. Two equal and opposite charges separated by a small distance. Whereas the second point, the effect of the dipole can be taken from the center of the dipole. I should not write can be, but it's okay. Must be taken. must be taken from the center of the dipole. And third one, electric dipole moment. Even in chemistry also people will teach you dipole moment. Yes, of course. So it's a magnitude. For that the magnitude is length into the positive charge, and it is having directed from negative to plus q. In board level they might be explained why minus q to plus q. Why? You think of it, we will see it on. But in board level it has to be completed. Okay, done? Now coming to here. The fourth point, immediately for this question, will it form a dipole? The by-hearters will by heart the statement two equal and opposite charges, but by seeing the question, there are no two equal and opposite charges, hence they will say no dipole system, which is completely wrong idea. Hence, for a dipole system, there is one rule, which is Q net is equal to 0. Yes, Q net is equal to 0. Now coming to the fifth point, when the length of the dipole, like when you see the aeroplane from your home, which is far away from you, it seems to be like an ant size. That means it's very short. That means such a case the dipole is termed as short dipole. Dipole is termed as short dipole. Yes, short dipole. The other name of short dipole is ideal dipole. This is what? The brief introduction of electric dipole. Now we will proceed on to the points. One more. Sixth point. Clearly, once again, whenever if you talk about a point, this is the dipole moment direction, this is point 1 and this is point 2. From the center r distance, and this is point 3, which is also at r distance. You have to understand that this point, whereas this is minus q plus q, this point is called as, point 1 is called as, on its line of axis, point 1 is called as axial point. Point 1 is called as axial point, whereas point 2 is called as general point, any point. General point, whereas point 3 is called as equatorial point. So please mind it, whenever they are asking the questions, you see which point they are giving, which point they are asking you the question. Understood? Just go through this for 1 second. Clear? Yes, done. We will move on to the problems now. So let us start with the problem. So please try to understand problem. Equilateral triangle. Here it is minus 2q charge. Here it is plus q. Here it is plus q. And the question is find net dipole moment. Find net dipole moment. Is it clear? Find net dipole moment. Okay. So if you talk about this, as I said, it is so crystal clear whether it is dipole or not. Yes, q net is 0. For this system, if you consider all three together as a system, q, 2q and minus 2q becomes 0, nothing else. Yes. So hidden thing we have to take it out. Let me find out. This minus 2q can be written as minus q plus minus q because yes, charge is additive. Yes, I am dividing that. So here I am keeping 1 minus q. Here I am keeping 1 minus q. Still the total charge is minus 2q only. Now what else? From negative to positive, dipole moment will be there, which is P. From negative to positive, one more dipole moment is there, which is also P. Actually speaking, this is P1, this is P2, but all the distances are identical, even charges are identical, so I can guarantee you P1 is equal to P2 is equal to P. Clear? And now see, so let me start then. In this direction, one vector is there, which is P. In this direction, the other vector is there, of course, which is also P. Our goodness, both are P. Hence, resultant must lie. Tell me, resultant must lie? Yes, along the bisector. This is along the bisector. Because none of them is bigger. So what was the answer? If this is theta, you know, this is 60 degrees, but bisector, so this will be theta by 2, this will be theta by 2. Of course, you see, touching side is touching like your mother always very smoothly handling. So please believe in my words, touching, non-touching are very important. So here P, touching side will be P cos theta by 2. And one more touching side will be P cos theta by 2. Hence total is this. What about non-touching side? Yes, this is P sin theta by 2. Yes, this is also P sin theta by 2, where both will get cancelled. Where both will get cancelled. Hence, the final answer is, which is equal to P net. What was the answer? P net is equal to 2P cos theta is 60. 60 by 2 cos 30. Cos 30. Cos 30 root 3 upon 2. 2 get cancelled. Hence it is root 3P. Finally root 3P is length of the dipole into Q, which is A into Q, because A I took here. So this was the masterpiece answer. Hope so understood. Clear? Copy down. Just go through this slowly and steadily once again. How I analytically I explained. Clear? No tension. Slowly and steadily, you please go through this. Now coming to the next question, very important. Till now in competitive exams they didn't ask this, which is this is the thin wire of positive charge Q, and at the center there exists a minus Q charge, which is also a dipole because system net charge is 0. So now the question, this type of dipoles are called as distributed dipole. What was that? Distributed dipole. Clear? This is called as distributed dipole. Please make sure distributed dipole. So now clearly how to handle this? As per the definition we have minus Q and plus Q, but here we don't have. So let us see now. Take for the granting a small piece which is having charge dq, because we want point charges, not distributed one. 2 point charges. So now see, let me take here clear, this is of dq charge. Yes, do you remember last class we discussed linear charge density? Then for this dl, of course dl will be r d phi. Let me take it as phi, and this will be d phi. Integration matters here. Practice thoroughly. Now that side and this side, so 2 times integration. But beforehand, let me discuss. This is a dipole moment dp. Clear? And you see this is phi, so touching side is dp cos phi, non-touching side is dp sin phi. Yes. Now the question arises. At the same time, here also the mirror image will be there. Even for this also phi will be there, and for this also dp will be there. Then this will be dp sin phi this side, dp cos phi this side. Yes. Then what will happen? Any guessing? Yes. What? dp sin phi get cancelled. Only we left with dp cos phi. So integration p net will be integration 2 times of dp cos phi. Clear? Limits 0 to phi by 2. Make it sure. Here to here 90 degrees, here to here. Yes. That is what the story. Okay, done? Clear? Now see, if I take an arc like this for your better understanding, if this angle is phi, if this is q, if this is minus q, and I divided into 2 segments, so that side phi by 2, this side phi by 2, that is what my idea. So you can see here, what is dp? Tell me what is dp? Yes, it will be, think once again, it will be dq into r. Why? Dipole moment is charge into separation. Separation is radius into cos phi. But what is dq? Yes, you have to understand. Unitary method, we discussed uniform distribution. Total by total, dq by dl is equal to, correct, total by L. Then dq will be absolutely dq is equal to q by L into dl. What is dl? R d phi. Yes, if I substitute that here, 2 times integration q by L, already r is there, r square into cos phi d phi. What is L? L is arc length. L is equal to r phi. Yes, I can write it as r into phi. R get cancelled. Finally, you have to stick on to the formula. This much integration you may feel bit hard, but practice this. So this will be 2 times of q taking out by phi taking out cos phi d phi. Cos phi d phi integration cos phi d phi sin phi. Absolutely, this is what the idea behind this. Clear? Now the limits. Limits will be 0 to 5 by 2. Hence, final answer will be P is equal to 2q by phi into sin phi by 2. Make sure, of course, minus sin 0, upper limit minus lower limit, sin 0 to 0. That's all. Yes, this is the answer. No, required formula for the question. So please, by heart, practice this formula thoroughly. Now see, as per the question, this is semicircular ring. So 180 degrees. So this is 180. On the top R also left, ma. If you see carefully, this 1 R is left. Yes, 1 R is left. So final answer for this, substituting P is equal to 2QR by pi, because pi by 2, 90 degrees, sin 91. You have to be number 1. Remember, practice makes you perfect. So this is the final answer. Make sure and revise it properly. Once again, let us see. I took the concept first, a small arc length, q minus q, but I want a small charge. Yes, dq for this length dl, and here the angle is d phi. Arc length is equal to radius into angle subtended. Yes, everything is clear. So now see this part, this side. Yes, minus q2 positive, that will be the dipole direction dp, touching side, non-touching side. Even this side also mirror image, touching side, non-touching side. Yeah, this get cancelled. And remember, this is left. Some people will ask me, sir, 2 dp cos phi, na, why you didn't wrote like that? Yes, I wrote, of course. But this side, na, 0 to 5 by 2, 0 to 5 by 2. That is what I wrote. If I don't want to write 2, I have to write here 0 to 5. Remember, 0 to 5 only into dp cos phi. Clear? And then everything will be clear. Hope so understood. Read it, practice it thoroughly. Clear? So now we are extending the topic. We are extending the topic of electric dipole to find electric field intensity due to a dipole. So please try to understand. So electric field intensity due to a dipole. So here there are three general cases. The first case, in your board level, these are very important, but we are discussing about competitive level, but still let me discuss at least the formulas and the concept. So listen carefully. Case 1, electric field due to a dipole on its axial line. On its axial line. So please make sure about this. What do you mean by axial line? Yes, this is minus q, this is plus q, axial line, and this is 2a. Axial line means yes, here that is called as axial point. And every distance first of all should be measured from the center. Clear? Yes. Now see here, you studied very well. From here to here, what is the distance? Yes, here to here, that is a. Here to here, that is a. Obviously this will be r minus a. Whereas from this minus q till here, this will be r plus a. Now tell me, what is the electric field at that point? At this point, if you concentrate, electric field due to plus q will be outward, which is E1, let me say. Electric field due to minus q will be inward, which is lesser, E2, let me say, because distance is far, kq by r square, field strength will be less. So finally, the net field will be in this direction, because that side will dominate. So what was that? So let me write at least the first step. Electric field on its axial point will be E1 bar plus E2 bar. Of course, you studied in board. What is E1 bar? Due to 1 here, kq upon r minus a square, because kq by r square. Clear? Both are in same direction. So no need to worry, plus k. But here this is minus q by r plus a square. Then after solving this, directly I am going to the concept k q, and here r plus a square, here r minus a square will come. Clear? Then a square, r square, a square, r square, a square get cancelled, and you will get, what you will get? 2r a. Clear? Here 2RA, here 2RA. Yes, this will become 4RA upon A minus B, A plus B, A square minus B square. Of course, the whole square. And this 4 can be written as 2 into 2. This 4 can be written as 2 into 2. Now you see, 2A into Q can be written as P. Then final answer is 2kp r by r square minus a square, the whole square. This is electric field on its axial. But in competitive level, generally they won't go for the board level. They usually they will ask about short dipole. What do you mean by short dipole? For short dipole, Remember, for short dipole, R greater than A. R is much more larger distance when comparing with the size. Then R square minus A square is written as R square. Then R square whole square R power 4. And top R get cancelled. Arthaita? R power 4 get cancelled. Then final answer, E axial due to the short dipole will be 2kp upon R cube. Yes. Due to point charge by R square, k cube R square. Due to dipole by R cube. Due to quadrupole by R power 4. This is what you have to understand. Okay, done? This is all about axial line. Now, point number 2. Electric field at equatorial point. As I discussed, this is minus q, this is plus q, minus q and plus q. And you can see here this is 2a. Equatorial point means this, which I already taught in basics, right? So at this point, which is at r distance, yes, this is a, this is a. Now please try to understand what is this distance. This will be, tell me, under root of r square plus a square. Even this will be under root of r square plus a square. But electric field at this point will be in this direction. Let me say that is E2. Similarly, electric field due to this at this point will be in this direction. Let me say this is E1. Then, quite interesting. What is E1? E1 is kq by r square. Square root get cancelled. R square plus a square. What is E2? kq by r square. Once again, r square plus a square. Your goodness. Both are same in magnitude. Hence, if both are same in magnitude, resultant lies along the bisector. Hence, yes, perfect. What was that? See, this is theta, this is theta, this is theta, then this is also theta. Net will be, due to this E, touching side E cos theta. And due to this E also one more E cos theta. Total 2E cos theta. That's all. Very simple. Understood? So E net will be 2E cos theta. है ना बेटा? 2E cos theta. अर्धा है दमा? 2E cos theta. That's all. Now 2, what is E? kq by r square plus a square into cos theta. Cos theta is a by under root r square plus a square. You can see cos theta adjacent side upon hypotenuse. Now I am rounding off 2qa. 2a into q is dipole moment kp by, this is whole power 1, this is whole power 1 by 2. Hence it is whole power 3 by 2. R square plus a square whole power 3 by 2, which is E net. I hope you understood. But direction matters. You see, electric field direction is like this. This is E net. Whereas dipole moment direction is like this. Means both are opposite in nature. I have to mention minus sign here. This is what the story. And at the same time, what about the short dipole? For short dipole, answer is E net is equal to minus kp by r cube. Please mind it. Very, very important. What is the difference between this and that? Seems to be in magnitude. This is double of that. So I can relate them. E axial is equal to minus 2 times of E equatorial. That's all. If they are asking field intensities ratio, not magnitudes, E axial by E equatorial, magnitudes not they are asking vectorially, then answer minus 2. If they are asking just magnitudes, answer will be 2. So that's all. Please revise, go through this once again. Then we will keep on moving into the problems. Now, the third point, at any general point. So, at any general point, third case, E bar at any general point, due to a dipole. That means short dipole I am considering minded. So this is P, general point here, R, which is making an angle theta. It's quite simple. This is P. So in this direction, P cos theta will be there. In this direction, P sin theta will be there. Hope so understood. Now forget about this pink color line. So we have two dipoles. One is P cos theta, and due to this P cos theta, this point is axial point. Hence 2kP by R cube. Hope so understood. Right? 2kP by R cube, and due to this P sin theta, this point is equatorial point. Yes, it is like this, then anti-parallel, just now we discussed, minus sign. So this will be kP sin theta by R cube. Then when two vectors are there, resultant should be there, which is E. So directly I am writing, both are already perpendicular. E net will be, remember, kP by R cube into under root over 1 plus 3 cos square theta. This is the equation. If you want, you can solve that. That's up to you. Clear? Now see, you can cross check. On axial point, you can cross check now. Theta is equal to 0. Yes, this point lies here, then theta will be 0. Cos 0, 1, 1 plus 3, 4, under root of 4, 2, 2kP by R cube. Wow, wonderful. Clear? Now, on equatorial point, theta is 90 degrees. Theta is 90 degrees. So theta is 90 degrees. You can see, yes, when it goes here, theta becomes 90. Clear? When theta is 90, that's all. Cos 90, yes, 0. So root 1 is 1. Then answer is magnitude wise equatorial line Kp by r cube. That's all for the session. So we will keep on, move on to the problems. So I'll catch you in the next session. Thank you. Till then, happy practice.